Okay, good afternoon, class. Right, so we continue. So last time we see about reactivity of metals, right? So you see how does metal react with oxygen, right? So we see video about magnesium, right? How does magnesium when it react with oxygen, it will glow brightly, okay? And then from that, we can make a series, the reactivities series of metal, okay, based on the reaction, okay, based on the reaction between the metal and the oxygen. Okay, so that one we already see, I think like 2 weeks ago. Okay, so let's continue from that. Okay, so this is actually the experiment. Okay, when the magnesium, okay, react with the oxygen. Okay, so what will be formed here, you can see the magnesium, okay, it burns very brightly. You already see the video. Okay, so mean very reactive, and for the copper it's just glows dimly. Okay, and I mean it's a less reactive. Okay, and for the zinc, okay, for the zinc, it burns brightly, so it's reactive. But for lead, it just glows brightly, okay, but it's less reactive than zinc. Okay, so from that we can make a series, the reactivity series of metal. Okay, so the reactivity of metal decreases, okay, from magnesium, zinc, plumber, and copper. So the most reactive one is the magnesium, and the least reactive one is the copper, okay, or copper. Okay, so this one also already see the video. Okay, so this is the equation. So let's say magnesium. So magnesium when react with the oxygen, it will form magnesium oxide. Okay, for the zinc, okay, zinc react with oxygen, it will become zinc oxide. Okay, but for non-reactive metal means there is no reaction. Okay, so like the element like silver, gold, and platinum. Okay, they are they are in the form of elements, right? So means they are very least reactive. So they will not react with the oxygen. Okay. So also already see the video. Okay, so this is the reactive series of metal. Okay, so the first one, the most reactive one is the potassium. Okay, or sometimes we call it as the calcium, right? And the less reactive one is the gold. Okay, so this is the series of metal that you need to remember. Okay, so other than that, this is all of this is a metal. Okay, so how about the carbon or hydrogen? Okay, so they are not a metal. So where are their position in the series of metals? Okay, so that one we see after this. Okay, so first one we see the position of carbon, okay, in reactivity series of metal. So carbon is a non-metallic element, okay, but it can react with oxygen to form a carbon dioxide. Okay, so carbon plus oxygen will become carbon dioxide. Okay, so the position of carbon in the reactivity series can be determined by comparing its reactivity towards oxygen with other metals. Okay, so example, let's say magnesium oxide, okay, and then when you react it with the carbon, so it will just form magnesium, okay, and we form carbon dioxide as a gas. Okay, so that is the example, right? So if carbon is more reactive than other metals, it will glows or bright flame will be seen when the mixture of carbon and metal oxide is heated. Okay, so the metal losses is oxygen to carbon. So the metal losses is oxygen to carbon. So the carbon will combine with the oxygen and it will form the carbon dioxide. Okay, so this is the equation. So I just give you just now, let's say the magnesium oxide, right? So let's say the equation is magnesium oxide, right? So when it react with carbon, okay, and it been heated, right? It will form a metal. So the metal here is a magnesium. Okay, the metal here is magnesium. And the carbon we combine. So this carbon we combine with the oxygen here to form the carbon dioxide. So this one in the gas form. Okay, so how you want to test whether it is carbon dioxide that been released? So you can use the lime water, right? The lime water will turn into the cloudy, right? Okay, so this one they use a zinc oxide. So zinc oxide plus carbon, when it heated, it becomes zinc plus carbon dioxide. Okay, so this one means the carbon is more reactive than the zinc. Okay, so if they can take away the oxide from the metal, okay, so mean they are more reactive than the metal. Okay, so if the carbon less reactive than the other metal, no glow or flame will be seen when the mixture of carbon and the metal oxide is heated. So there is no reaction. Okay, nothing changed. Okay, so example here like aluminium oxide, okay, plus carbon. So when you heat it, there is no sign of reaction. So means there is no flame. Okay, there will be no flame or there is no glow. Okay, so that means there is no sign of reaction. Means the carbon is less reactive than the aluminium oxide. Okay, so the carbon is less reactive than aluminium. Okay, so now we see video. So for this part, you don't need to know. This one is actually the higher level one. When you learn chemistry, form 4, you will learn this one. Okay. So this one is just the one that I said just now. You add the magnesium oxide or you add the zinc oxide with the carbon. Okay. Then we heat it. It will produce a flame there. Okay, so then it will produce the zinc, okay, and the carbon dioxide will be released. Okay, okay, you can see this one, right? So just now we can conclude. So when you react the zinc oxide with the carbon, okay, there's still a reaction. Okay, so means there will be the zinc oxide plus carbon, you will produce zinc plus carbon dioxide. Mean there is a reaction. So means carbon is higher, the position of carbon is higher than zinc because it can react with the zinc. Okay, but when you react the aluminium oxide with the carbon, right, there is no reaction. So means the aluminium is more reactive than the carbon. So that's why there is no reaction. If the metal you want to react, it must be the lowest level. So let's say from ferrum. Okay, so ferrum carbon can let's say this one I put the example like ferrum oxide. Okay, ferrum oxide. Okay, so ferrum oxide plus carbon, it can produce ferrum and carbon dioxide, right? So means why? Because ferrum is lower position than carbon. So this means for aluminium, magnesium, calcium, sodium, potassium, okay, carbon cannot react with this, okay, with these 5 metals. Okay, only the below part of it, like zinc, ferrum, tin, lead, copper, the one mercury cannot because that one is element, right? Okay, so below from the carbon, yes, can react. Okay, but upper than the upper like aluminium, magnesium, calcium, sodium, potassium, they cannot react because this one is more reactive than carbon. Okay, so only this part. So You can see here before the experiment is like the experiment. Okay, when you try to react the carbon with aluminium, there is no reaction. So means the position of carbon is below than the aluminium. But when you react with the zinc, okay, it can react. So means it's higher than zinc. So the position of the carbon is between aluminium and zinc. Okay, so that's the position of the carbon. Okay, so carbon is a less reactive than magnesium and aluminium. So thus carbon cannot reduce aluminium oxide. So example like potassium oxide. Okay, so potassium oxide cannot react with carbon because carbon is potassium is higher position in than the carbon. Okay, so that's why it cannot react. So carbon dioxide is used in fire extinguisher. So however, this type of fire extinguisher cannot put out fire of reactive metal like magnesium. So let's say there's a fire, right? And there is a magnesium involved in that fire. The carbon cannot react, cannot put out the fire because magnesium is higher position than the carbon dioxide. Sorry, than the carbon. So magnesium, which is more reactive, can remove oxygen from carbon dioxide and continue to burn. So let's say because now we already know that magnesium is higher level than the carbon, right? Means it's more reactive than carbon. So when you react the magnesium with the carbon dioxide, it can take the oxygen from the carbon dioxide and produce the magnesium oxide. Since because it has a higher level than the carbon. So let's say if I put calcium oxide, or let's say I put the natrium oxide, right? So natrium, so let's say I have a natrium here, okay, natrium, okay, and then I heat it with the carbon dioxide, okay. Since the carbon dioxide, the carbon is less reactive than natrium, okay. So the natrium can take the oxygen from the carbon to produce the natrium oxide, okay, and the carbon will be alone like that, okay. So that means for the this one, okay, let's see the reactive series of metal. No, not like this. That one is on the video, right? Never mind, I see it. Okay. I cannot fast forward it. Okay, just for you to know, you don't need to write the form of equation like this, okay? You only have to write in the words like this. This one is actually when you learn in the chemistry form 4, yes, you have to put like this. But for your level form 3, only you put in the equation like this, in words only. Okay, you cannot fast forward this video. Okay, so for this one, right? Okay, for this one, they say I give you an example. Okay, for this is carbon, right? So this one, it means the most reactive. Calcium, natrium, calcium, magnesium, and aluminium is more reactive than the carbon. For zinc, ferrum, tin, lead, copper, mercury, silver, gold, this is the least reactive, okay, if you compare with the carbon. Okay, so let's say for the at the upper part here, right, for potassium, sodium, calcium, magnesium, and aluminium. Okay, so let's say if I have the calcium oxide, right? Okay, calcium oxide, no, calcium plus carbon dioxide. Okay, calcium plus carbon dioxide. Okay, carbon dioxide. Okay, and because of the calcium, okay, calcium is the most reactive than the carbon, so it can take away the oxygen from the carbon to produce the calcium oxide. Okay, and they can release the and then it will release the carbon here. Okay, but for the zinc, ferrum, tin, lead, copper, mercury, and silver and gold, okay, so let's say they got let's say I have a ferrum oxide. Okay, I just give you the example below there. So ferrum oxide plus carbon. Okay, okay, and then they will form, since carbon is more reactive than the ferrum. Okay, it's more reactive than ferrum, so it will produce the it will take the carbon will take the oxygen from outside here, so it produce ferrum, okay, plus carbon dioxide. Okay, so means from at this part, okay, since this one, the calcium, natrium, calcium, magnesium, aluminium is more reactive, so it can take, okay, whatever the carbon here have, okay, and form a calcium oxide, metal oxide. Okay, but since this one, carbon is higher reactive than the zinc, ferrum, tin, lead, copper here, so it can, carbon can take the oxygen, okay, from the metal oxide here to produce the carbon dioxide, and it will leave the ferrum here. Okay, so means there are two types of equation that you need to remember. Okay, so this one is when the since the carbon is less reactive than the metal here, the potassium, sodium, calcium here. So this one, the potassium can take the oxygen from the carbon dioxide here, okay, to produce the metal oxide. But this one, the carbon, because they has a higher reactive, they are high reactive here compared to below here, so they can take the oxide from the metal here to produce the carbon dioxide. Okay, so there are two types of equation here. Okay, so this is the example. Okay. So the next part is actually carbon and hydrogen in the reactive series of metal. Just now we see the carbon only, right? So now we only see the we see about hydrogen. Okay, so where is the place for the hydrogen in the reactive series of metal? Okay, so hydrogen is below zinc. Okay, so thus the metal above hydrogen, okay, cannot remove oxygen from steam, forming hydrogen gas. So this is the example. So the zinc plus H2O, this means is the H2O is the gas form of water. Okay, so zinc plus H2O, okay, will form zinc oxide and hydrogen. So hydrogen is a gas. S mean is a solid. Okay, it's a solid. So zinc is in the solid form. Okay, H2O means the water vapor, right? It's a water but in the kind of gas. So water vapor. So it will form zinc oxide and it will release the hydrogen gas. Okay. So figure below shows the apparatus setup used to determine the position of hydrogen in the reactive series of metal. Okay, so this is isoprene. So inside of it, you got the dilute sulfuric acid plus copper sulfate solution, and this is the zinc, right? This is the anhydrous calcium chloride. This one is actually to make sure that the gas flows through the tube here will be dry. Okay, it will absorb the water. Okay, and then after that it will form the dry hydrogen gas here. Okay, so the burning excess, this is the combustion tube. Okay, this is burning of excess hydrogen gas. You can see there is a flame produced here. Okay, so this is the metal oxide on the porcelain plate. So metal is a calcium oxide, right? So this is the metal oxide inside of it. Okay, so this is the setup for the experiment. Okay, so the experiment result means C. Okay, so the mixture is hydrogen plus aluminium oxide. So when the hydrogen plus aluminium oxide, the aluminium oxide does not glow. Okay, so the aluminium oxide is in white color. Hydrogen does not reduce aluminium oxide. So does not glow means there is no reaction. So when no reaction means you have to know that the aluminium is more reactive than hydrogen. So that's why there is no reaction. Okay, then if you react the hydrogen with the zinc oxide also does not glow. So when it does not glow means zinc oxide is more reactive than hydrogen. So that's why it doesn't have any reaction. And then the zinc oxide turns yellow when hot and white on cooling. Okay, and hydrogen does not reduce zinc oxide. Okay, and then we see about the iron. So hydrogen and iron oxide. So the iron oxide burns brightly. Okay, so means there is the reaction, right? So mean hydrogen is more reactive than iron. So that's why there is a reaction. So iron 3 oxide burns brightly. So then we produce the reddish brown powder turns shiny gray. So iron is produced. So hydrogen reduce iron oxide to iron. So there is a reaction means hydrogen is more reactive than iron. So now we know that if the position of the hydrogen is higher than iron but lower than zinc. Okay. And the next one is a hydrogen and lead. So lead oxide burns brightly. So the yellow powder turns shiny gray. So lead is produced. Hydrogen reduce lead oxide to lead. So there is a reaction means the hydrogen is more reactive than lead. Okay. Or plumbum. Sometimes we call it as a plumbum. Alright, hydrogen and copper oxide. So you can see there is still a reaction, right? And the black powder turns to brown. Okay, so copper is produced. Hydrogen reduce copper oxide to copper. Okay, so that means the position of the hydrogen is higher than copper because because hydrogen can reduce the copper, right? Means there is a reaction. So when there is a reaction, means the position of the hydrogen is higher. Okay, so where is the position of hydrogen? So let's see the video first. This one you don't need to know. Okay. Okay, so let's see the reactivity series here. So just now we know that when hydrogen react with zinc, there is no reaction. So means hydrogen cannot react with zinc because zinc is more reactive than hydrogen. So now we know that the hydrogen is below zinc. Okay, and then when we react this hydrogen with ferrum, right? So you can see from the ferrum oxide, it become the ferrum and it release H2O means water, right? Okay, so means you know that hydrogen is more reactive than ferrum. So that's why they can react and they can form the metal and also water, right? Okay, so means the position of the hydrogen is between zinc and ferrum. So the hydrogen is between it, okay? So just now like carbon cannot react with, can react with zinc but cannot react with aluminium. So we know that aluminium is more reactive than the carbon, but it's the carbon is less reactive than aluminium, but more reactive than zinc. So the position is between aluminium and zinc. Okay, but for hydrogen it cannot react with zinc. So means zinc has is more reactive than hydrogen. But hydrogen can react with ferrum. So means the ferrum is less reactive than hydrogen. So it will the position of the hydrogen is between zinc and ferrum. Okay, so now your reactivity series is already complete. Okay, why we didn't complete we didn't just put the carbon hydrogen together just now, from the starting, because this one is a reactive series of metal, and you know the carbon and hydrogen is not a metal. There are kind of carbon is not a metal. Sometimes hydrogen is a gas, right? So like you cannot you cannot include it earlier. So we have to do another experiment to conclude, all right, the hydrogen and the carbon. So where is the position of them, right? So now this is the one. So from here, go from the upper part to the below part, all right. So the reactivity is decreasing. So we add the carbon and the hydrogen. So this is the series of metals. So this one you need to remember. All right. So that's all for today. So next part I will teach about okay. Mm, Okay, so the next part I teach you about the extraction of metals from their ores. And I already assigned for you an exercise for the reactive series of metal in the GC. So I hope you can answer it. And please take the attendance for today. Who is your monitor here? Can the monitor give me the attendance later? So thank you for attend to my class today. So I see you um, tomorrow. Do we have a class tomorrow? No. I'll see you on Wednesday. Right? So thank you, class. Okay, welcome. Bye.